Jai Hind, myself Nidhi Singh. I am Assistant Professor in AKGEC Engineering College. Today I am going to discuss the theory examination which was held in 2023-24 question paper for Fundamentals of Electrical Engineering. Subject code is BW101. So, this is for the semester 1, that is BW101. So, this is the examination paper which came in session 2023-24 semester 1. So, the total marks is of 70 marks. So, this is the section A. In section A, you have to attempt all the questions, and there are total 7 questions in this section, and each question carries 2 marks. So, the first question which came is differentiate between ideal voltage source and practical voltage source. So, the question can also be come as a differentiate between ideal current source and practical current source, right? Then B part, this is also from the unit 1. This is describe briefly the following elements with example. The first is unilateral and bilateral elements. Second is active and passive element. Then question C is derive that the average power consumed by the pure inductor is 0. This can become, the question can be changed as a derived that the average power consumed by the pure capacitor is 0, right? Both the ways the question can come. Then question number D, in a series RLC circuit, R is equal to 2 ohm, L is equal to 2 millihenry and C is equal to 10 microfarad. Find the resonant frequency and Q factor, that is quality factor. This is from unit 2. The C and D both are from unit 2. Then question number E, this is from unit 3, and here the find the inductance of coil in which current of 0.2 ampere increasing at a rate of 0.4 ampere per second represent the power flow of 0.4 watt. It is written 0.3, but this is actually from unit 2. Then question number F, what is the function of slip ring in 3-phase induction motor? And then the last question, which is from the unit 5, what are the common problems that occur during electrical installation? So, we will discuss these questions one by one. So, let us take question number 1. So, question number 1 is differentiate between ideal voltage source and practical voltage source. So, the ideal voltage source, these sources are defined as the energy source which gives constant voltage, right, which gives constant voltage across its terminal irrespective of the current through its terminal. So, you can see in this circuit, here this is the voltage source, and here this Vs and Vl, we will get the same value irrespective of this load current, like, so load current is increasing, but we will get Vs is equal to Vl. So, these kind of sources are called ideal voltage source, and at any time the value of voltage at load terminals remains same, and this is indicated by the VI characteristic. So, if this question comes, what you are supposed to write? You are supposed to write the definition of the ideal voltage source. You are supposed to draw this circuit, right? And you are supposed to draw the VI characteristics of the ideal voltage source. Similarly, if it comes from the for the current source, you will also write the definition. You will draw the circuit of the ideal current source, and you will draw the VI characteristic for the ideal current source, right? Now, what is a practical voltage source? Practically every voltage source has some small internal resistance, right? They have a small internal resistance with voltage source, and which is represented by RSE, and this is the circuit for the practical voltage source. And now obviously, if there is a small resistance in series with the voltage source, there will be some drop. So, now this Vs and Vl are not equal. So, practically you will not get the straight line, but there will be a small drop in this with increasing of this IL, right? So, this Vs is equal to what? This is VL plus IL plus RSE, right? So, here VL is equal to Vs minus IL RSE. So, if this value of IL, if this value of IL is getting is increasing, this value of IL is increasing, obviously this VL will decrease, right? So this is how you can answer this question. That is differentiate between ideal voltage source and practical voltage source. So three things you have to write: definition, then you have to draw the circuit and draw the VI characteristic. So this will be the complete answer for this question. Then the question number 2 is describe briefly the following elements with example: unilateral and bilateral element, and the second part is active and passive element. So unilateral element, these elements allow current to flow only in one direction, and their behavior changes if the direction of current is reversed. So the example is diode or transistor. So if we know that in diode, if this is terminal A and this is terminal B, if current flow from A to B or B to A, right, in one direction it will be in forward bias, and in other direction it will be in reverse direction, right, reverse bias. So its behavior gets changed by changing the direction of the current. So these kinds of elements are called unilateral elements. Whereas bilateral element, these elements allow current to flow equally in both direction, and their behavior remains the same regardless of the current direction. So if we, examples are resistance or inductor. So if we take the example of resistance, and if this is terminal A and this is terminal B, if current is flowing from A to B or from B to A, the behavior of the element will remain same. It will not get changed, right? So if these kinds of elements are called bilateral elements. So unilateral element, they allow the flow of current only in one direction, and their behavior gets changed if the direction of current is reversed. Whereas bilateral element, these elements allow the flow of current in both the direction, and their behavior remains changed if we change the direction of the current. Like in resistance, we know if the current flow from A to B or B to A, the behavior does not get affected by changing the direction of the current. Now the next part is active and passive element. What are active element and what are passive element? So active element are those elements that delivers or produce energy or power in the form of voltage or current, right? So active elements are those elements which can provide energy to the circuit, right? So like voltage source or current source, they are good examples of the active element. Like batteries, they are the good example. They provide energy to the circuit. Then the passive element are those that utilize or store energy in the form of voltage or current. So passive elements, they are those elements which utilizes or store energy. Like the resistance, it uses the energy or dissipates the energy, and the inductor or capacitor, they stores the energy, right? So these are the examples of passive elements. So R, L, C, they are the example of the passive elements. Then the next question, derive that the average power consumed by the pure inductor is 0. So we know that the instantaneous power. So first we should know the instantaneous power. So instantaneous power is instantaneous voltage into instantaneous current. So if instantaneous voltage is Vm sin omega t, so instantaneous current will be equal to Im sin omega t. And we know that in purely inductive circuit, current lags voltage by 90 degrees. So this will be Im sin omega t minus pi by 2, right? So solving this, we will get the instantaneous voltage. And if we want to find the average power, so we will integrate this instantaneous power for the full cycle and divide by the base length from 0 to 2 pi, right? So if we integrate this instantaneous power, so the similar thing is done here. The average power, so to find the average power, we are integrating this instantaneous power for the time period of t, and the base length we have taken t. So if you integrate, you will get the average power is equal to 0. Similarly, you can solve it for the purely capacitive circuit also. If the question comes for the capacitive circuit, the similar procedure you can follow for the capacitive also. The only difference is that there the current leads the voltage by 90 degree, right? Then question number D. In a series RLC circuit, R is equal to 2 ohm, L is equal to 2 millihenry and C is equal to 10 microfarad. Find the resonant frequency and quality factor. So, we know that for the series resonant circuit, the formula is FR is equal to 1 by 2 pi under root LC, right? So, the value of L and C is given. So, under root L value is given 2 millihenry. So, you will write 2 into 10 power minus 3 and into 10 microfarad. So, this will be equal to 10 into 10 power minus 6 farad, right? And if you will solve this, you will get the value of the resonant frequency. Similarly, you can find the quality factor, which is equal to 1 upon R under root L by C. So, R is 2 ohm. So, 1 by 2 under root L, again L is 2 millihenry. So, 2 into 10 power minus 3 and C is 10 microfarad. So, this will be 10 into 10 power minus 6. So, if you solve this, you will get the quality factor. So, resonant frequency, you will get 1.125 kilohertz, and if you solve the quality factor, you will get the answer is 7.071, right? So, this is the required answer for this question. So, this is a very simple question. Similarly, the question can come to find the, can come for the parallel circuit also to find the resonant frequency and the quality factor for the parallel RLC circuit, where RLC value will be given to you, right? So, these are the formula based question, 2 marks questions. Then question number E, find the inductance of a coil in which a current of 0.2 ampere increasing at a rate of 0.4 ampere per second represents a power flow of 0.4 watt. So, here you have to find the inductance of a coil in which a current of 0.2 ampere is increasing at a rate of 0.4 ampere per second and represent the power flow of 0.4 watt. So, here the power we know is equal to V into I, and the power is given 0.4 watt. It is given 0.4 watt. You can write 0.4 watt, and the current is given 0.2 ampere. So, from here you can find the value of V, right? So, and you know the relation V is equal to L di by dt, right? We know this relation V is equal to L di by dt. So, we have found that V is equal to 2. So, you can write in place of V as 2, and the di by dt is given in the question, the increasing rate of 0.4 ampere per second. So, this is nothing but di by dt, right? So, this is 0.4. So, L is equal to 5 Henry. So, from this relation we can find that L is equal to 5 Henry. Then, what is the function of slip rings in 3-phase induction motor? So, the slip rings in 3-phase induction motor, we know that in 3-phase induction motor we have 2 kinds of rotor. One is sorry, a squirrel gauge, and the other is slip ring or phase wound rotor. So, the question is asked, what is the function of slip rings in 3-phase induction motor? So, we know that slip rings allow connection to external resistance. We can connect external resistance to the slip ring, which help control the starting torque and current of the motor. So, we know that the starting torque, it depends on the rotor resistance. So, by controlling the resistance, we can control the starting torque. Then, adding resistance to the rotor circuit improves the starting torque while reducing the high inrush of current. So, by adding these resistance to the rotor circuit, it will improve the starting torque, and this will reduce the high inrush of the current. By varying the external resistance, the motor slip can be adjusted, providing speed control in the industrial application. So, the main function like slip rings, through the slip ring we can add the external resistance, and this will control the starting torque. This will also control the high inrush of the current, and we can control the speed of the motor, right? So, these are the function of slip rings in 3-phase induction motor. Then, what are the common problems that occur during electrical installation? So, this question is from unit 5th. So, the common problem like improper wiring and loose connection. Like, so loose or improperly connected wires can lead to spark, overheating and fire hazards. So like for example, loose neutral connection may cause voltage fluctuations. Then overloaded circuits, connecting too many devices to a single circuit may cause overheating and circuit breaker trips. Like is using multiple high power appliances like heater, air conditioner on the same circuit, right? Then incorrect wire sizing, using wire with inadequate thickness can cause excessive resistance and heating. Like for example, using a small gauge wire for high current appliances leading to potential fire hazards. Then faulty grounding, missing or improper grounding increases the risk of electric shock and equipment damage. And like for example, not connecting ground wires in outlets and electrical panel. So these are the total questions of section A. So in next part we will discuss section B. Jai Hind.